Okay, so I think we are going to make a start. Apologies, everyone, for the short delay, and welcome again to the fourth International Recovery Towards Net Zero Symposium here. To those of us who are joining in Lviv, good morning. To those of you who are joining us online, good morning, good afternoon, and good evening. My name is Jamie Woods. I'm an architect and urban planner with UN Habitat, working here on recovery planning in Ukraine. And I am the co-chair of the Track 2 Reconstruction Technologies Processes with Mykhailo Shevchenko. I'll shortly hand to Mykhailo to introduce our track and our busy program that we have for you today. However, there's just a couple of quick housekeeping items to address. So firstly, to all of you joining here in the room, there is simultaneous interpretation available via the headsets outside. Please make sure that you're on the correct channel. And to those of you who are joining us online, please make sure you're making use of the Zoom facility and to make sure that you're on the correct language version on that. Whilst we, of course, hope that there will be no air raid alert today, in the event that there is an alarm, we will have to temporarily relocate from this facility. So to those of you who are joining us online, please just bear with us for a couple of moments whilst we relocate. We might lose some of the videography, but we should still be able to continue our program just from another location, and we will relocate as soon as the alert is finished. So I will hand firstly to Mykhailo, who will give some more introductions, and then we will begin with our first session straight away.
Good morning and welcome everyone. And I'll start with introducing myself. My name is Mykhailo Shevchenko. I'm an architect, educator, and researcher. I'm a part of a team of the Department of Architecture Spatial Development in Lviv City Council and co-founder of NGO Materia Lab. And today I'm happy to introduce our track, Reconstruction Industries, Technologies and Processes. So this track actually explores how Ukrainian reconstruction could become a driver for net zero, for climate resilient future, and how we can work within the conditions which we have, but to provide the change. We will hear from Ukrainian and international speakers about real-world projects, which shows first steps in it, which shows how it's possible to change the industry, how to work within building industry with all of its restrictions and difficulties, but to try introduce these changes, how to try to provide new projects with sustainable materials, working with net zero approach, and to finally see the ways of change. Our main questions today are actually lowering emission in different scales, in different projects and topographies, and how we can, how actually it's possible in the scale of small objects, in the scale of actually state program, let's say. We will also speak about materials, about material research, and about bio-based materials, work with rubbles, and all these like severe topics which we are facing now in Ukraine. I will talk about regulations a lot because every time we start to speak about reconstruction, we start to speak about adaptive reuse, about material research, we always have this topic, and we can't avoid this elephant. So we need to understand how to actually make it possible to use it, how to make possible shift in the way we work and way we build. So regulations and certification of materials will be the big topic today. So let's start.
Thank you very much. So I think for our first session, we should have Professor Toru Kobayakawa, who is joining us from Japan this morning, or rather this evening for him. To open this track, Mykhailo and I wanted to first contextualize the scale of the challenges facing Ukraine and to really set forward the agenda for the following sessions that come later in the day. So I introduced Toru, and then I'll give you the floor to share your screen and begin the presentation. So Dr. Toru Kobayakawa is a professor in the College of International Relations at Nihon University, and he is a visiting fellow at the JICA Ogata Sadako Research Institute for Peace and Development. His research focuses on sustainable consumption and climate change mitigation. And before joining Nihon University, he held senior positions at JICA, including working on the energy sector development and support for Ukraine. So Toru, thank you again for joining us this evening. And I give the floor to you now, if you can share your screen and begin your presentation. Thank you.
Sure. Can you hear my voice?
Yeah, we hear you well. Thank you.
Okay, thank you so much for inviting me to this valuable event. My name is Toru Kobayakawa. So good morning, good afternoon, and good evening from. I'm speaking from Tokyo now. So it's a bit evening in Tokyo, but yes, let me start my presentation as Jamie introduced. Can you see the screen?
Yeah, I think we're just trying to get it onto the main screen. We can see your screen now. If you start your presentation, we'll move it onto the main screen.
Okay,
Thank
sure.
you.
Yeah. So as Jamie introduced, I was working for a JICA, Japan International Cooperation Agency, which is the bilateral donor agency under government of Japan. I shifted to the university faculty, which is quite close to Mount Fuji. So I can enjoy the beautiful view every day. But today, I would like to make a presentation on estimation of the carbon footprint of post-war reconstruction. Sorry, of Ukraine. And I know that it is very crucial to Ukraine for Ukraine recovery to achieve green recovery through the Build Back Better approach. Ukraine is now a candidate for EU membership, and various reforms are already underway to move toward accession. It will be essential for Ukraine to rebuild its infrastructure, such as energy and transport, its urban forms, industries, agriculture, and environmental systems in line with EU standards during the course of its recovery process. Is the screen coming up?
Yes, we can see your screen. Thank you.
Oh, okay. So yeah, so this slide shows the life cycle of the infrastructure. Most discussions focus on operation stage and how to make it greener. For example, compact urban planning, efficient infrastructure, cleaner energy, and better building insulation would reduce emissions during the operation stage. So this part. This is very important, of course, in the longer perspective. However, there is another side to the story. Infrastructure construction itself produces a large amount of CO2 because it requires vast quantities of materials and energy. So this process is shown in the red box on the diagram. So this part involves producing construction materials like steel and concrete and using heavy machinery to build infrastructure and buildings. So while working at JICA on Ukraine's recovery support, I came to believe that we should also focus on minimizing CO2 emissions in this part of the reconstruction process. So with that in mind, I conducted this research aiming to estimate the carbon footprint associated with the reconstruction of Ukraine and propose feasible measures to reduce the carbon footprint of the reconstruction process. I will not go into detail about the research methods today, but using an input-output table, it is possible to estimate CO2 emissions from the reconstruction process, the part highlighted in the red on the previous slide. For this analysis, I used the EORA26 database, which includes data for Ukraine. In addition to estimate emissions, we need information on what types of infrastructure need to be rebuilt and how much this reconstruction would cost. So this purpose, I relied on the results of the Rapid Damage and Needs Assessment, RDNA, conducted by the World Bank, the United Nations, the government of Ukraine, and the European Union. The RDNA has been conducted 4 times so far, Because Russia's attacks are still ongoing, the estimated cost of recovery has continued to increase with each assessment. In my study, I used data from RDNA3. So if the newer RDNA4 data were applied, the estimated CO2 emissions from reconstruction would be even higher. As shown in the figure below, the recovery costs required over a 10-year period under the Build Back Better approach have been estimated for various sectors, totaling about 486 billion US dollars. On the lower left side of the slide, you can see a simplified breakdown of the reconstruction costs estimated by RDNA. On the right side is the corresponding amount of CO2 emissions, which I estimated in this study. As a result, it was found that the reconstruction process in Ukraine would generate approximately 741 million tons of CO2. Notably, the construction sector alone accounts for about 77% of the total emissions, highlighting the importance of improving its efficiency. According to several studies, Ukraine's construction sector faces challenges such as low labor productivity and frequent rework due to the inadequate design, which need to be addressed to reduce emissions. This estimated 741 million tons of CO2 emissions is equivalent to about 4 years worth of Ukraine's total annual territorial emissions before the war. It also corresponds to around 26% of the total territorial CO2 emissions of all EU 27 countries in 2022, indicating that this is quite a large amount of emissions. Based on these results, I believe that two key approaches are necessary for Ukraine's reconstruction process. First, there is a need to modernize Ukraine's construction sector. By introducing digital technologies such as building information modeling, BIM, it would be possible to improve precision and efficiency of design and construction, thereby reducing CO2 emissions. It is also crucial to ensure transparency and fairness in the tendering and the implementation stages of construction projects to prevent inefficiency and waste. I understand that the government of Ukraine, with international support, is already working on institutional reforms in this area. Secondly, since emissions from the construction sector also include those generated in the production of materials such as steel and concrete, it is essential to reduce CO2 emissions from construction material manufacturing. For example, reducing debris from destroyed buildings could help limit emissions generated during the production of new materials. Advancing these efforts would also support Ukraine's path toward EU accession as they align with the EU's decarbonization agenda. If Ukraine develops a recycling industry for construction materials, it would benefit both sides, helping the EU promote low carbon materials while giving Ukraine a strategic advantage as it moves toward EU membership. As a result of these efforts, if the carbon intensity of Ukraine's construction sector could be reduced to a level comparable to that of Germany's construction industry, the carbon footprint of the reconstruction process could be cut by more than half, from 741 million tons to around 334 million tons. Although Germany's construction sector still has a relatively high carbon intensity compared to the other EU countries, it could serve as a realistic and meaningful benchmark for Ukraine as it moves towards EU membership. Japan also has experience in managing and reusing debris. The photo shows a scene from the reconstruction process after the Great East Japan earthquake, where local governments employed residents to carry out meticulous waste separation. In Higashi Matsushima City, for example, a 99% recycling rate was reportedly achieved. Such cases highlight that community engagement plays a crucial role in advancing these kind of initiatives. International development agencies such as UNDP and JICA have already started pilot projects in Ukraine. as well to test debris management and recycling possibilities. The photo shows one such pilot project in Borodianka, Kiev Oblast, where heavy machinery provided as ground aid is being used to process debris. Since some of the debris contains asbestos, strict safety measures are being observed. The lessons learned from this project are also being shared with several other municipalities, including Kharkiv. Finally, let me introduce a couple of Japanese companies that are producing building materials made from recycled debris. A company called Aiki sells materials that can be used to manufacture road repair products from debris. Another company, Tagawa Sangyo, has developed a technology to produce tiles, construction materials, tiles from debris, and remarkably, these tiles can absorb CO2. Both companies are eager to contribute to Ukraine's reconstruction and are currently considering expanding their business to Ukraine with support from the government of Japan. Lastly, I would like to express my sincere hope that Ukraine will achieve a green recovery through a Building Back Better approach and move towards a bright and prosperous future. So thank you so much. Jack Yu. ありがとうございました。
Is that coming through? Yeah. Thank you, Toru, for the presentation and for joining us again. We have some time now for questions and answers from the audience, both here in the room, but we also invite those who are joining us online to submit your questions in the chat, and we will try to come to as many as we can. Maybe just one from me, Toru, to begin. Your presentation and your research introduces another soberingly big number in terms of the way that we can consider the scale of recovery facing Ukraine. Often we speak about the scale of the economic damage or the scale of the human impact, the scale of the number of buildings destroyed. But here we have the benefit of your research, which brings in the number of the projected CO2 emissions. And I think this is a moment maybe when the immediate reaction that we feel in the other numbers, there's maybe more of a kind of a step back and a reflection on how big this number is with respect to projected CO2 emissions. Your presentation also highlights that there's possibility for Ukraine to really modernize its construction sector here in terms of the way that it pursues this recovery. And so maybe my question to you is the need to recover and to rebuild is a pressing and time-considered concern here in Ukraine, but maybe the need to offset that with a consideration for longer term and the consequences of this large-scale emission. So where do you see the tensions between this immediate recovery and maybe the longer-term considerations of carbon emissions?
Yeah, Jimmy, thank you for your question. So I'm actually optimistic about the tension point. So reforms of improving, as I mentioned in the presentation, already some institutional reforms have already been undertaken under support from the international donors, like improvement of procurement process. And also during the full reconstruction process, I think there are many international donors and the international construction industries are coming in. And the entire, most of the reconstruction project will be undertaken internationally. So even domestic Ukraine construction companies need to align with this, procurement process with the transparency and high fairness. So it's like more like a learning by doing process, I think. So the reconstruction process with higher efficiency will be undertaken simultaneously with the immediate addressing with immediate needs. So I think a reconstruction process already has started. So yeah, the Ukraine can pursue both. Oh, Jamie, I can't hear you.
Sorry, can you hear me now? Yeah.
Yes.
Yeah, we share your optimism that this recovery and pursuing lower emission recovery as possible. And I think in the later sessions we have here today, we'll hear from practitioners who are working on these topics firsthand and are sharing some examples of how we can achieve this. Maybe I'll open up to the room to see if there's any questions at all, and then we can also go to online.
Hello. Добрий день. Hello. Thank you very much for the presentation. I have maybe a more practical question about asbestos-containing debris. Is there any potential you can share from Japan? Is there any potential technology for recycling such materials and to produce new one? Thank you.
Over then, yes, as far as I know, thank you for your question. As far as I know, there are no particular technology which can make recycling of asbestos possible. So only thing we can do is carefully remove these asbestos from the waste rubble and carefully put in separately handle these material asbestos and maybe put underground with the strict control. So that's the measure which Japan has been taking, and also that part also has been shared with our Ukrainian counterparts. So yeah, maybe they will come up with the guidelines.
Good afternoon, evening, morning, I don't know. Thank you very much for your presentation. I have the question about the, could you please maybe share your vision concerning the environmental compliance during the recovery of Ukraine, especially during the martial law, where we need to recover the damaged infrastructure regularly, and in the post-war period? What to pay attention, first of all, from your experience, maybe for the experience of Japanese, and maybe the worldwide experience, if you have any insights to be shared. I will be grateful to you. Thank you very much.
Thank you for your question. Yes, the situation which Ukraine faces right now it's I think quite challenging in terms of making a full recovery. It will take a very long period of time. Maybe the contamination of the land is quite complex. I think you have a Russians buried many mines, anti-humanitarian mines. So you need to remove mines and clean up the soils, and so there are plenty of things you need to do to handle environmental damages. So I think there wouldn't be shortcut. I think in other countries like Cambodia, it took 20, 30 years to remove landmines in the beginning, and also clean up the land, soil also takes lots of time. And also in Japan, after tsunami hit the eastern part of Japan, and also we had the problem of nuclear power plants, and they have been heavily contaminated. So the government need to remove the soil and clean up the land, and it also it took a long time, like 10 years. So yeah, I think there are many things there to be done, and yeah, maybe international community will provide necessary knowledge and technology with Ukraine and maybe remove all these obstacles one by one. That's what we can do. So, yeah, am I answering your question?
Yes, thank you very much, but I apologize, I have another question based on your answer. And how can we use the debris from the damaged objects? I mean, reuse these debris? Because in Ukraine, we have a lot of amount of such debris, and I think that's not rational just to take it to the landfills, and we can reuse somehow this debris. Do you know any technologies, or maybe you can share any links just to study this subject? Thank you very much.
Yes, thank you for your question again. The first thing you need to do is separate segregate different types of debris. And maybe you can segregate steel or concrete or some other toxic material like asbestos. And then maybe if you find some useful materials like a concrete, then you can reuse that material for for recycling purpose. So for example, like I showed in my presentation, there are several companies which have some technology or products which enable that kind of recycling. So maybe what you need to do is separate the rubble first and apply some certain technologies for reuse of these rubble and waste.
Great, thank you, Toru. I think, the questions from the room and also your presentation highlight that this issue of ground contamination and reuse of materials is a really pressing question here in Ukraine. And the session that we have following will discuss some of these ideas in further detail. I wonder whether we could ask you maybe if you could just share one or two more thoughts about the work you're doing here in Borodienko, or that JICA were doing with the waste debris and the processing. I think I know that maybe it's familiar to some people here in the room, but it's a really interesting topic, and I'm sure it would be great to touch on that if you can. Thank you.
Yeah, thank you. Unfortunately, I'm not quite deeply involved in that pilot project. But what I heard is that things are quite complicated since some toxic materials like asbestos are also within this waste and rubble. So you really need to carefully handle these material before actually moving on to the recycling process. So yeah, that's what I can share.
Sorry, my mic thing. No, absolutely. I think so in UN Habitat, we are working also in Borodienko, and we see that the issues that you raised about landfill and about debris management are going hand in hand now. And these discussions are really the kind of first steps about recovery and processing, and what do we do with contamination of materials and land, particularly with consideration to pursuing a greener, sustainable recovery. I think we have time for one more question. I'm not sure if there was any online or if there's anyone in the room. Yep, we have one here online.
Okay, so we have a question from Hago. Have you studied the use of alternative technologies such as cross-laminated timber to replace some of the high carbon materials?
Yes, I've heard of that material. I think we came up with once some construction project, and one of the designers proposed to use this CLT since I think Ukraine produces this CLT, I think, if I'm correct. And so that's I think a big opportunity since these days many construction have been undertaken utilizing this timber material, wood material. So I think that's another possibility for Yeah, so using this kind of technology, yeah. But that project hasn't been materialized, unfortunately. So, but there is a possibility, I think.
Yeah, great. I think we also have some projects which are coming up later in the program that also explore the use of CLT and the way that it can be used as part of low carbon recovery as well. I think unless there are one more question from the room, but if not, maybe we can close. Toru, thank you very much again for your presentation and for contextualizing many of the conversations that we will be having here in the following programs. Thank you again for joining us and taking your Friday evening. And yeah, we look forward to continuing discussions with you. Thank you.
My pleasure. Thank you.
So I think now we can take maybe just a quick 5-minute break. And then when we return, we will have the second session, which is reconstruction through material innovation and looking at the use of reused debris and bio-based materials. Thank you.